Everyone. Welcome to week one, what I'm calling week one, I guess week one online, let's say. I said at the beginning of this, before we left for spring break, which feels like forever ago, that some of the more difficult stuff I will either do videos or voiceovers to kind of give you an idea, maybe a different idea, since you're used to hearing me explain things. So these are optional. You don't need to listen to them, but hopefully they're going to help. So in this chapter 9, we first start talking about this idea of product of labor or marginal product of labor. And just want to talk about some of the math. So what this says, this first column is the amount of labor, or we can say just the amount of workers. How many people do we have working for us at one time? Maybe at 10 a.m. we have 3, at 11 we have 4, something like that. The total product is the amount of output or quantity that we're producing. So if we have 0 workers, we're assuming that they can't make anything. But if we add workers, they can make more things. So maybe if we think about ice cream sundaes, we need someone to actually, scoop the ice cream, add all the toppings. We can't just, have nobody working, just have machines, at least at this time. So then we have 2 other columns. One's called the marginal product of labor, and the other is average product. So does anybody remember when we talked in the beginning of the semester, when we talked about what the idea of marginal was, what that meant? Remember, that's this change in. So really, we want to see how much does total product change when our workers, the amount of workers we have, changes. And let me write this up. And apologize now, my stylus isn't very good. I need to buy another one, which I will soon. But the marginal product of labor is equal to this change, or delta, in the output quantity or total products. I use Q here, but you can put TP at the top. And then at the bottom is the change in the amount of workers. Luckily for you, though, as we're going down 0 through 8 workers, we're just going up by 1. So we can actually just consider this the change in output or the change in total product. This is how much, again, our output changes by adding 1 more worker. See, my stylus is messing up a bit. All right, so let's get down to it. As we said, we have 0 output for these ice cream sundaes that, we want to sell to make money when we have no workers. So we need to add workers to get sundaes out to our customers. If we move from 0 workers to 1, this person can make 10 sundaes. That marginal product, or the change, is, we can say 10 minus 0. So we're looking here and subtracting the 1 above it. And that also is just 10, right? Nothing too difficult there. So we're just subtracting. So we have 10 sundaes, but now we want to think about what happens when another worker comes in. So we're going from 1 to 2 workers. The 2 workers together can make 25 sundaes. So we want to do the same calculation, just taking 25 and subtracting 10. I'll write that down so you have it. And that's 15. So the second worker added 15 more sundaes to production. And then we can go on, and this is in your slides, but you're taking the row that you're looking for, you're taking that output or total product and subtracting from above. So the next one is 45 minus 25, or 20. I think you can all do this. So just subtraction. Now the other thing that we have in a column, and first I want to note In the first row where we have 0, we can't compute the marginal product or the average product. So we just have dashes there. You won't have to fill anything in for those. So the average product of labor, this is kind of the output per worker. That is just equal to the total product over, I was going to try to erase that with my finger like I'm on the blackboard, over just L. So no changes, no subtraction. We're just taking the number produced and dividing it by how many workers there were. So this one is 10 divided by 1, which is just 10, right? And we have then 25 divided by 2, which 12.5. If you get a decimal, try to round to maybe 2 decimal places unless it comes out even, like 12.5. And you're going to continue down. The next one is 45 divided by 3. It's 15. So I'm not going to go through all of this, but make sure you understand. Again, this table is in your book. So let's go down to the picture. So your book graphed this for us, so we don't have to. In the top part, we have total product. So how much Sundays are we producing? It's here with the amount of labor. Labor is on the x-axis. And then in the graph below it, labor is still on the x-axis, but now we're looking at the marginal products or the average product. So red, marginal product, blue, average product. And total product for the most part is increasing. So we have more workers, they're being productive, and they produce more output. That's probably what we would expect. However, if we keep adding workers and keep adding workers, we have 10, we add 5 more, we have 15, we add 20 more, there's going to get to a point where there's too many workers. You've ever heard the phrase, too many cooks in the kitchen, right? So I'm local and I love Alora's ice cream in Pittman. But if you've ever been in there, it's a very small shop. It's a local thing. And you can't have 50 workers working there. You can't have even 25 or 10. You need to have just enough to get through your customers and getting everything else done. But if you had too many, you're going to be running into each other. You're going to be using the machines when another person needs to use it. And some people are probably going to slack off, right? They're going to say, oh, I'm not going to get a turn to use the milkshake machine, so I'm not even going to get this guy his milkshake, right? So too many people, we're actually going to see total product fall. And in your table, if we went to go through everything, this would fall in total. I'm sorry. We do see that the total product starts falling or doesn't go up a lot. So that is actually seen here. So we're increasing as we're going down, go to 60, 70, and then our change is 75. So we're going up a little bit, but at 7 units, we actually didn't add any more Sundays. Workers are not paying attention, they're not doing their work. And so our output is exactly the same here. But then if we go down some more, go to 8 workers, we actually lose total product. That's because people are maybe talking, or they're not paying attention. They're sitting down on break, even though it's not their time to have a break. They can't all work on getting ice cream to customers because there's not enough room. So output actually falls. So that's what this top graph shows. So then below it, in red, we'll talk about marginal product first. Marginal product is going to increase. And again, look at your either your book or the slides to see those numbers. And after a certain point, it starts falling, and that's okay. You'll definitely see this happening in most examples, and it's even becoming negative at the end. Totally fine, not an issue. So marginal product can be positive, negative, or zero itself. And I really need a new stylus. It works fine when I'm working by myself and not trying to do it on the spot. But I'll get that soon. So then, so positive, negative, or zero for marginal product. And then just looking at our average product, where this is in blue, we're increasing again, but then we start falling. That shows that having more workers and we're producing less and less output, or we're not increasing our output by a lot, it starts decreasing. Average product is always going to be positive though, right? All right, I'm going to stop there for now, but then I'm going to talk about cost next. So stay tuned if you want to hear me talk about that. Thanks.